Good evening everyone. My name is Devanand. I am faculty of Heat Transfer in ACE Engineering Academy, Hyderabad. So I welcome you all to the very first session of GENCO, TS GENCO for mechanical engineering. So today's agenda is to discuss about some strategical plan about the examination, and there are some important question analysis. So first of all, hope you can hear me clearly. First of all, hope you can hear me clearly. So if there is any issue regarding voice and all that, so you can write in the comment box. Okay. So let's start the session today. Now, so this video is, the agenda behind to make this video is not to aware you about the competitive exams. Here I am not going to discuss about any other competitive exam. Here our aim is totally talk about the TS GENCO, especially for mechanical engineering. So make sure that this video is not for the GATE and this video is not for engineering services. This video is typically for TS GENCO. And suppose if you want to get the information about GATE, engineering services, UPSC, other exams and all that, so you can visit our channel ACE Online. So you can go to the YouTube and type ACE Online. You will get the new infinite videos, many videos you will get on the particular topic. You can access that. But today's agenda is to discuss about the TS GENCO. So without wasting time, let's get started. So once again, I welcome you all and thank you for watching this video. It is important for me that you are giving your time to watch this video. So definitely I will try my level best to give you the valuable knowledge about these exams and especially about my subject. Okay. So let's get started. Okay. Let's get started. Now, as see, remember, for any examination, so there are infinite information is available on the internet. Do this, something like that. But what I believe, first of all, you need to understand the exam very well. So what happens, students are trying to say that they will prepare completely so that they can attack all the examination. This is true up to some extent, but what I feel, as per as, first of all, you need to see what examination you are going to prepare. Accordingly, you have to adjust yourself. Like suppose you are going for a GATE examination, then in the GATE examination you have virtual calculators. So you need to prepare accordingly that. Then if you go for engineering services, then in prelims you don't have calculators. So similarly for your examination, there is no calculators. So if there is no calculator, what to do? How to solve with a round of values and all that. So if you catch the exam, then 50% your job is done. 50% job is done. So if you find a lengthy expressions in a topic, you will understand that this expression cannot be solved without any calculators. So that topic you can skip it. Okay. So when there is no calculators, so mostly the questions will base on the fundamental theoretical questions you can expect. And if there are some numericals also, that numericals also very easy based upon the common equations, which will be which don't require any calculators and all that. So the heart of any examination, so listen, heart of any examination is about the syllabus. So what I am trying to say, syllabus is like you should understand where you are going to put your energy. So suppose if you don't know syllabus, so let us say you are following ACE material or any other institute material. So definitely that material is with respect to exam only. But what I am trying to say, you need to first go to the syllabus and check what we need to prepare. Now here I will show you one difference. So in the first line, it is written modes of heat transfer. So it is clearly written modes of heat transfer. So suppose if you take modes of heat transfer, this is the modes of heat transfer. So if it is a modes of heat transfer, it is clearly understood that conduction, convection, radiation are included. Means no need to ask whether radiation is there or not, convection there or not. Conduction, convection, radiation is by default included. Right. Next one. If you see here, then it is very important, I feel, it is written one dimensional heat conduction. Now suppose if you open any book of heat transfer, any book, whatever the book you followed in your engineering, if you open that book, you will find there are two-dimensional equation, three-dimensional equations are there. So 2D also there, 3D also there, various cases are there where properties are changing with respect to temperature and all that. This not required. This is not required. So you can save your energy by preparing only one dimensional, because it is in the first point in the syllabus it is clearly written that it is one dimensional only. So if the question comes to 2D and 3D in the books, don't solve, don't put your energy. Okay. After that, resistance concept, electrical analogy, heat transfer through the fin. So it is also mentioned, it is fins. So fins is a part of syllabus. Then unsteady state heat conduction. Okay, this is also part of conduction. Now here it is clearly written lump parameter and Hessler chart. So make sure these two topics will save your time, because in unsteady state there are 5-6 methods are there. So other methods also there, but in the syllabus it is clearly written that ki lump parameter system and Hessler chart. So these are the two topics only you need to prepare. So what I said to you, two-dimensional, three-dimensional conduction, no need to prepare. In unsteady state there are 5-6 methods are there in the books, no need to prepare. Only you need to prepare lump and Hessler chart. Then there is called thermal boundary layer, dimensionless parameter. So it is written here free and force convection heat transfer. So force convection also there, free convection also there. But in that, listen, heat transfer correlations for, it is clearly mentioned that it is for flat plates and through pipes. That's it. So it is clearly written that heat transfer correlations flow over a flat plate and through pipes. Means no need to study sphere, no need to sphere any trapezium, no need to sphere any other geometry. You need to prepare only flat plates and pipe. Simple. Only you need to prepare flat plates and pipe. If you go to the books, if you open the books, you will find out various cases in convection. Sphere is there, trapezium is there, half cut section of the pipe is there, open channel is there. No, not required. Not required. It is clearly written that it is flat plates and pipes. Simple. After that, effect of turbulence in heat exchanger, you have only two methods. What are the methods? LMTD and NTU. So these are the two methods are mentioned. Others you know not required. Then after that, radiative heat transfer, Stephen-Boltzmann law. In that Stephen-Boltzmann law, it is written here, Stephen-Boltzmann law. Then you have wind displacement law, then black body, gray surface, view factor, and radiation network analysis. So these are some important area. Right, which are highlighted. Now the question is, sir, what to do? What to do for examination? So exam is very near. What to do? So make sure that like my professor used to say, and still I believe that whatever he said that is correct only. My professor used to say, he used to say, if you are good at 70% of anything, then you are the champion. So initially what I thought, I need to prepare everything in a very detailed manner. But I was wrong, because at the end what happens, if your 70% is damn good, out of the total syllabus 70% is very good, then you can crack any exam with a single digit rank. And I am the part of ACE Academy, and ACE Academy has huge rankers. From many years I saw the many single digit rankers came. And whenever we interview them, they will only say one thing, I skip this portion, I concentrate this portion. So make sure revision play a very important role. That was my feeling, and most of my colleagues are also believe the same thing. So suppose if you prepare only one time prepare, then you cannot make a difference. But if you repeat 2-3 times, then automatically your understanding level will increase, your speed will increase. So practicing test series is of course a good thing. You need to practice a lot, but make sure you need to select the limited areas, cover that area with a repetition. Repeat that thing. And suppose if you are weak at 1 or 2 subjects, I don't think so that makes a difference. Okay, 1 or 2 subjects, I don't think so ki anyone have all subjects are good. I don't think so. 1 or 2 subjects you are weak, that is absolutely normal thing, absolutely normal thing. Getting tension about the examination, reading but I am forgetting, I don't know what to do. These are all the things will happen with the student life as the exam is very near. So you are not the something like special for everyone. Human memory is made in such a way that we should forget easily. So we will forget. If you not revising, then things will keep on forget. It's not about student. For me also, I am teaching this subject. That's why I am in a flow. If I lose the contact of the subject for years, then gone. Again, I have to prepare very well. Okay, so that's what the logic. So in that case, if you ask me one thing, ki sir, tell me some areas you need to tell me. So what I'm trying to say, listen, what I'm trying to say, there is something called, listen everyone, something called Fourier law. Okay, listen. So there is something called Fourier law of heat conduction. Of heat conduction. Fourier law of heat conduction. Right. So Fourier law of heat conduction is what? Q is equal to minus Ka delta T by delta X. So this is the equation, Fourier law of heat conduction, that without this equation you can't do anything. So this equation you should know. You should know. Suppose if you apply this equation in case of plane wall. In case of plane wall. So let us say you are applying in case of plane wall. So this part is a L. This is T1. This is T2. And there is a heat transfer. So heat transfer in plane wall. Heat transfer in plane wall, that is T1 minus T2 by L by Ka. L by Ka. So listen carefully. So of course T1 greater than T2. T1 greater than T2, where area is perpendicular area to heat flow. Perpendicular area to heat flow. So A is perpendicular area to heat flow. So this is the formula. Now why I did not took like a cylinder or sphere? Because in cylinder and sphere, like logarithmic term is coming. So calculation without calculator is little bit tricky. But here you will find most of the questions based upon this formula. And remember, Q by A is small q, that is heat flux. That is heat flux. So small q, that is heat flux. So this equation you should know, Fourier law of heat conduction, where K is thermal conductivity. K is thermal conductivity, area is perpendicular area, and make sure I cannot go each and everything detail because I cannot cover in a 1 hour. So I need to get touch of all the topics. So this is the equation I feel you need to remember. Next, listen. Then you have something called Newton's law of cooling. Newton's law of cooling. This is for convection. This is for convection. So what you can write? Q is equal to HAS delta T. So this is Q convection. This is Q convection. This is the equation that you need to understand. Remember this one. Okay. So this is for convection. Now, if you go to the radiation, then you have something called Stephen-Boltzmann law. Stephen-Boltzmann law. Most of the questions will fall from these three equations. Stephen-Boltzmann law. What this law said? Emissive power of black body directly proportional to T raised to power 4. Emissive power of the black body directly proportional to T raised to power 4. So first of all, what I am trying to say, I am giving you some hint ki what you need to prepare. What you need to prepare, first you need to understand ki this is the Fourier law, this plane wall equation you should know. Then in Newton's law of cooling, HAS delta T. Then in radiation you have Stephen-Boltzmann law. So if you remove the proportionality, then you will get sigma T raised to power 4. Sigma is Stephen-Boltzmann constant. Stephen Boltzmann constant. So Stefan Boltzmann constant, so sigma is equal to 5.67 10 raised to power minus 8 watt per meter square k to the power 4. So these are the things I feel you should remember. You should remember this one. Okay, these are the things you need to remember. And there is one more equation, that is Wien's displacement law. Wien's displacement law, where lambda t is equal to C3, that is 2898 micrometer Kelvin. Okay. So what is lambda? Lambda is peak wavelength. Peak wavelength. T is temperature in Kelvin. So lambda is a peak wavelength. Lambda is a peak wavelength where T is temperature in Kelvin. So lambda T is equal to C3 2898. So easily you can write like this: lambda 1 T1, lambda 2 T2, lambda 3 T3 is equal to some constant. Some constant. So what is peak wavelength? Peak wavelength means this is the wavelength where the energy carried out maximum. This is the wavelength where energy carried out maximum. Okay, that one. So suppose if you take this heat transfer, in this heat transfer, first of all, Fourier law you should know. You should know about some thermal conductivity also. Then in that, plane wall. Plane wall equations are important. So once again I am telling you, this you need to take it very important. Plane wall, especially plane wall equation. Then you have Newton's law of cooling. Then you have Stefan Boltzmann law, and you have wind displacement law. That is important. This is important, right? Then after that you need to prepare critical thickness, critical radius RC. So critical radius RC you need to prepare. So in this case, for cylinder, RC is equal to K of insulation by H of outside. This is the formula for cylinder. Then for sphere, RC is equal to 2K insulation. 2K insulation by H outside. So these are the two formulas you need to understand. See, I am just giving you brief view, okay? So what to prepare? So for cylinder, RC is equal to K insulation by H. For sphere, RC is equal to K insulation by H. Okay. So now this graph you need to remember. Okay, listen. So this is radius. This is radius. Okay. So this is RC. This is RC. So at this radius, Q will be maximum. So here Q will be maximum. So make sure this is the radius where at this radius Q will be maximum. Now suppose if you are below this, so this graph is follow like this. So if you are not insulating, means you are insulating before RC. Suppose this is this one, from here you are starting insulation. Suppose you are starting insulation from here, then heat loss is increasing. So this is Q. This is Q. So in this case, R is less than RC in this case. So heat loss increasing. Heat loss increasing. In this case, there is a heat loss increasing. R is less than RC if. And suppose if you go to this domain, if you go to this domain where R is greater than RC, if you cross the RC, then heat loss decreases. Heat loss decreases. Heat loss decreases. Okay. So remember one thing. This is the cylinder. RC is equal to K insulation by H. For sphere, 2K insulation by H. So you will get the radius. RC, and whatever the radius is given in the question, if that radius is less than RC, if it is less than RC, then due to insulation the heat loss is increasing. And suppose whatever you are insulating that is greater than RC, if it is greater than RC, then heat loss decreases. So please listen carefully. Now see, I will show you one question, this question, so that it will be clear for you. Okay. Now, so if I take this question, then this will be very easy for you to understand. See, what is this question? A pipe of 25 mm outer diameter. A pipe of 25 mm outer diameter carries steam. Okay. The heat transfer coefficient between cylinder and the surrounding is 5. So 5 watt per meter square Kelvin given. It is proposed to reduce the heat loss from the pipe. By adding the insulation of thermal conductivity 0.05 watt per meter Kelvin. So which of the following statement is true? So because of this material, whether heat loss increases or decreases, that we need to check. So what you need to do, please listen. First thing, it is for cylinders. So this is for cylinder. So without wasting time, you need to calculate RC. So that will be K insulation by H outside. So K insulation, that is 0.05 by H. What is H? That is 5. So this will be 10 mm. So for cylinder, this is 0.05 by 5. So this will be 10 mm, let us say. Now this will be 10 mm. So what I am trying to say, this is the RC for cylinder first. This is RC for cylinder. Then now you check the pipe of 25 mm diameter he manufactured. So he already manufactured. So what is the pipe? If you see, diameter is 25 mm. So radius, this radius is 12.5 mm. 12.5 mm already he manufactured 12.5 mm. But for cylinder, whatever the material you are insulating, with that material H, so you are getting 10 mm. Okay, 10 mm. Now what I am trying to say, the radius is greater than RC. Okay, so this is radius. This is radius. If you follow this graph, something like this. So this is the graph, right, where it is RC, and here you have Q max. So here you have Q max. This is Q max. Now what you understood, ki RC is 10 mm, but he already manufactured 12.5. So we are already here. So already you are here. So this is 12.5 mm. Now you are landing here, and suppose if you insulate, suppose you are insulating, so you are reaching to decreasing heat loss zone. So R1 is greater than RC due to insulation. heat loss always decreases. Always decreases. Because you are landing to this region. If it is below the 10 mm, then situation will be different. Below the 10 mm, situation will be different. So, due to insulation, heat loss always decreases, right? So, what does it, first option says, the outer radius of the pipe is equal to critical radius. No, outer radius is 12.5, critical radius is 10. So, this is not correct. So, option A, not correct. The outer radius of the pipe less than critical radius? No, it is not less. So, this is also not correct. Then adding the insulation will reduce the heat loss? Yes. Why? Because R1 greater than RC. So, this should be the right option. This will be the right option. Adding the insulation will increase the heat loss? No. This is also not correct. So, the correct option is C. Correct option is C. Why? Because it's just a matter of R1 and RC. So, you have to check whether R1 less than RC or R1 greater than RC. So, listen now. Okay. So, that is the case. That is the case. So, what I am trying to say, this you have to check clearly. Ki whether R is less than RC or R is greater than RC, this you have to check. And accordingly you need to respond. So, this topic I am saying that critical radius topic, take it very important, because it don't require calculators and all that, very like fit for the GENCO exam. This topic clearly fit to the GENCO exam. Okay. And already I told you, you should know Fourier law, you should know Newton's law of cooling, you should know Stephen-Boltzmann law, you should know wind displacement law. This lambda is peak wavelength, right? So, see, this is one question. This is also exactly fit for GENCO exam. The emissive power of the black body is P. So, let us say the black body emissive power is P. If its absolute temperature is doubled, if the temperature is doubled, then emissive power become. Okay, then emissive power become. See, the examiner will put trap here. So, 2P. Listen. So, he want to trap you. Like if I increase the temperature, emissive power also get double. No. So, it is not linear in radiation. It is not linear. You can check. This is T raised to power 4. So, in this case, the expression is different. So, this is EB directly proportional to T raised to power 4. EB2 by EB1, T2 by T1 raised to power 4. So, EB2, this is P, this is 2 raised to power 4. So, that is 16. So, EB2 is equal to 16P. So, this should be the answer, because it raised to power 4. It raised to power 4. So, you should go for option D, 16 times P, 16 times P, right. So, whatever I am saying that, whatever I am teaching that doesn't mean the same question will come. What I am trying to say, what is for GENCO exam, how you need to prepare for heat transfer. So, these are some basic laws. Based upon the basic laws, how the question is framed. So, this is also fit for the GENCO exam, like it is 16 times P, right. Now, okay, this is one question. What is this question? The peak wavelength of radiation emitted by black body. So, here important is peak wavelength. The peak wavelength of radiation emitted by black body at a temperature of, at this temperature 2000, the peak wavelength is 1.45. The peak wavelength of radiation emitted by black body at a temperature of 2000 Kelvin is 1.45 micrometer. If the peak wavelength of the emitted radiation changes to, now the wavelength change. Now the wavelength change, now it is become 2.90 micrometer. then the temperature of the black body is. So in this case, which equation you will use? This wind displacement law. So this equation you will use lambda t 2898, no need. You can write lambda 1 T1 is equal to lambda 2 T2. So that you can write. So here, listen, you will use wind displacement law. You can use wind displacement law. So what is wind displacement law? Lambda 1 T1 is equal to lambda 2 T2. So lambda 1 1.45 into what is the temperature? 2000. Lambda 2, that is 2.90. What is T2? T2 we need to find. So if you see this one, 1.45, 2.90. So this is the ratio double. So 2000 by 2, that will be 1000 Kelvin. That should be 1000 Kelvin. So this is your answer. So this is your answer. So peak wavelength is 1.45 at this temperature 2000. If the wavelength is increasing, what about the temperature? So as you can see here, lambda 1 T1. As you can see here, lambda 1 T1, lambda 2 T2. So this lambda is inversely proportional to temperature. So as the temperature is increasing, lambda is decreasing. As the temperature is increasing, lambda is decreasing. So that's why your answer is 1000. So this is 1000. This is 1000. Okay. So answer is 1000. So this is wind displacement law. So in the radiation, you need to prepare two things. One, that what is black body. Second, you need to prepare what is Stephen-Boltzmann law and wind displacement law. This in radiation especially. In radiation, this you have to target. Okay. Then in the conduction, you have to prepare plane wall and critical thickness problem. Okay. And you need to read the theory of fins. What is the use of fins and all that. Right. Now, this type of questions also very common. This type of questions also very common. As the temperature increase, the thermal conductivity of gas is. So, thermal conductivity is one area where you need to study as per as the heat transfer point of view, not from the material science point of view. So, for metals, what will happen? For non-metals, what will happen? For liquids, what will happen? And for gases, what will happen? So, here, remember, from kinetic theory of gases. Kinetic theory of gases. So from kinetic theory of gases, what is the equation? Thermal conductivity of gas. Thermal conductivity of gas is under root T by M. So from kinetic theory of gases, what you can say, thermal conductivity of gas is equal to under root T by M. Right. So what is T? T is a temperature. T is a temperature and M is molecular weight. M is molecular weight. M is molecular weight. So this is the one equation I feel you need to remember this. This is the equation from kinetic theory of gases. K of gas is equal to under root T by M. Under root T by M, where T is a temperature and M is molecular weight. Okay. And what is the question here? As the temperature increase, okay. So as the temperature increase, listen. So here you can see K of gas directly proportional to root T. So as the temperature is increasing, so if the temperature increases, thermal conductivity of gas will increase. Straightforward question. Okay. Now, so please listen carefully. As the thermal conductivity of gas directly proportional to T, as the T increase, thermal conductivity of gas will increase. So in this case, you can opt for this one. So increase is the right choice. Increase is the right choice. Okay. So please listen, whatever I am teaching here, I am just want to hint you ki where you need to focus. So whatever question I am taking you, that topic you have to prepare. Suppose if I am taking the question of thermal conductivity, means you need to understand ki what I want to say. Ki thermal conductivity, you just read it. Stephen Boltzmann constant, Stephen Boltzmann law, you read it. Wind displacement law, you read. Fourier law, you read. Plane wall, you read. Critical thickness, you read. So it indirectly, the sessions what I am going to conduct, it's like an important area where you need to focus. So this is like an important area. Next one. Next one. So what is this? For hydrodynamically and thermal fully developed laminar flow. So here you should remember it's a laminar flow. It's a laminar flow. For hydrodynamically and thermal fully developed laminar flow through a circular pipe. Circular pipe. For constant cross section, the Nusselt number at constant wall heat flux and wall temperatures are. So in this case, this question is memory based. Okay. So please listen. Through laminar flow for pipes. For pipes, in that it is laminar flow. In that it is laminar flow. So for constant heat flux, constant heat flux. So for pipe laminar flow, constant heat flux. For constant heat flux, so you will have Nusselt number is 4.36. This is the memory you should have. You should have for laminar flow through pipe. For constant heat flux, Nusselt number is 4.36. 4.36. And for constant wall temperature, Nu is equal to 3.66. Nu is equal to 3.66. So for constant heat flux, Nu is equal to 4.36. For constant wall temperature, Nu is equal to 3.66. So it is clearly visible that Nu at constant heat flux is greater than Nu at constant surface temperature. So Nu at constant heat flux is greater than constant surface temperature. So you need to choose the options. NuQ greater than NuT, NuQ less than NuT, NuQ and NuT same, NuQ greater than NuT square. No. So here you can choose this one. So this is the right option. A is the right option. Why? Because based upon this memory, like constant heat flux having 4.36, constant wall temperature 3.66. 3.66. So these equations, I want to give some hint. These equations you need to remember for laminar flow through laminar flow. Constant heat flux 4.36. Constant wall temperature 3.66. So this relation you need to remember in convection. In convection you need to remember this. Okay. Next one. Next one. This question is very good question. Right. So, listen, for a flow of viscous fluid. So the first point he said viscous fluid. For a flow of viscous fluid over a flat plate, if, this is the most important point, if the fluid temperature is the same as plate temperature. Listen, for flow of viscous fluid over a flat plate, if the fluid temperature is same as the plate temperature, the thermal boundary layer is, immediately what happens, students will think, sir, it's a viscous fluid, so boundary layer will develop, viscosity and all that. Of course that is correct. But you need to read the question, what he said. He said about the thermal boundary layer. He did not say about the velocity boundary layer. So he said about the thermal boundary layer. Thermal boundary layer is a part of heat transfer, and the necessary condition for heat transfer is temperature difference. So temperature difference should be there. if there is no temperature difference, why we need to study this? There is no need to prepare, right? There is no need to prepare. So what I am trying to say, thermal boundary layer. Thermal boundary layer means there should be some heat transfer in that. And for the heat transfer, temperature difference should be there. But what is said here, if the fluid temperature is the same as the plate temperature, if the fluid temperature is same as the plate temperature, then there is no heat transfer. If Ts is equal to T infinity, then no heat transfer. Hence no formation of thermal boundary layer. No formation of thermal boundary layer. Thermal boundary layer. So there is no formation of thermal boundary layer. So in case of boundary layer, you should have some like clarity, like what is constant surface temperature, constant heat flux, and some theory you need to read. Okay, some theory you need to read. So here you can go for option D, not form at all. So in this case, you need to read the question very clearly. The fluid temperature is same as the plate temperature, so that is not form at all. Not form at all. So this is the case. Okay. Now, okay. Now let us say there is one more question. One more question. Before that, try to understand. This is the plate. This is the plate. So let us take this is glass. Let us take this is glass. So what will happen? Some amount of energy will incident here. So some amount of energy will fall, that is G. Out of which what will happen? Some amount of energy will reflected. So that is rho, reflection. Some amount of energy will easily pass, that is transmission, that is tau G. And some amount of energy will get absorbed, so that is alpha G. So this is absorption. So make sure G is equal to something get reflected, something get absorbed, plus something get transmitted. So if you divide by G, so G by G, OG by G plus alpha G by G plus tau G by G. So here you will get 1 is equal to rho plus alpha plus tau. 1 is equal to rho plus alpha plus tau. So this is reflectivity. Rho is reflectivity. Alpha is absorptivity. And tau is transmissivity. This is transmissivity. So reflectivity, alpha and tau. Make sure, please listen, if any surface, listen, if any surface having tau is equal to 0, if any surface having tau is equal to 0, transmissivity 0, then it is called opaque surface. So please listen carefully. If any surface having tau is equal to 0, then it is called opaque surface. Opaque means non-transparent. If it is not transferring, then it is called opaque surface. Generally solids, metal, non-metals, whatever we discuss, concrete, like silver, copper, gold and all that, these are all opaque. Sunlight cannot pass. Any energy cannot pass. So if any surface having tau is equal to 0, then it is called opaque surface. So this is the energy balance. Here 1 is equal to rho plus alpha plus tau. Rho plus alpha plus tau. So in radiation, these things you need to understand. Ki reflectivity, absorptivity, transmissivity, that you need to understand. Okay. So in this question, what is it? Again, important points. in a completely opaque medium. So he said opaque. What do you mean by opaque? Opaque means transmissivity 0. Opaque means transmissivity 0. If 50% of incident monochromatic radiation is absorbed, so how much absorbed? 50%. So absorption is 50%. Then which of the following statements are correct? Which of the following statements are correct? In a completely opaque medium, opaque means, listen, opaque means tau is equal to 0. Okay. Alpha is equal to what? 0.5, 50%. Which of the following statement is correct? So what we will write? 1 is equal to alpha plus rho plus tau. Tau is 0. So rho is equal to 1 minus alpha. So this is 1 minus 0.5. So that is 0.5. That is 50%. So in this case, listen, transmissivity 0, reflectivity 50%, reflectivity 50%, right? Absorptivity 50%. So this is the balance in this question. So in this question, this is the balance. Tau is equal to, tau is 0, rho is 50%, alpha is 50%. So you need to select the right option. So what is the first choice? 50% of the incident radiation is reflected. Yes, it is matching. Yes. So you can say yes. P is correct. P is correct. Next, 25% of the incident radiation is reflected. Is it 25%? No, it is 50%. So this is not correct. Then 25% of the incident radiation is transmitted. No, it is said opaque. Opaque means non-transparent. If opaque is non-transparent, so it is 0. So that is also not correct. R also not correct. The next point, no incident radiation is transmitted. Yes, so no incident radiation is transmitted. So this is also a right choice. This is the right choice. So P is 50% of the incident radiation is reflected. S is no incident radiation is transmitted. Okay. So what do you have? 50% of the incident radiation reflected. No incident radiation is reflected. So you can go for P and S. P and S. R is anyway not there. R is not there. No? R is not there. So B is not there. So this is not there. P and Q. 25% radiation reflected. No, this is also not there. So you should go for option A. P and S only. P and S only. So that is the thing. Now you see there is a huge difference. There is a huge difference between GATE preparation, engineering services preparation and GENCO preparation. Make sure that you should not prepare you should not prepare the subject for the sake of knowledge. Knowledge is a different thing. Writing in an exam is different thing. So you have to read the necessary fundamentals. Only that fundamentals which is required to solve the questions. Make sure you should not dig into the subject and don't take overload that I will prepare that and that. No. There is a particular topics are there which is very, very important. That you need to focus. Other thing, everything is no need to prepare. Once again I am telling you, if you are good at 60 to 70% of the topic, make 60 to 70%. Believe me, you will crack with a single digit rank. Believe me, no need to be like you are good at everything. No. So in heat transfer also, there are some topics where you can skip also. But there are some topics, critical thickness, Stephen-Boltzmann law, Fourier law of heat conduction, Newton's law of cooling, Finn's theory, convection, some numbers, like this. So these numbers are there, these numbers and all that. This theory, if you prepare this theory, then believe me, most of the questions you can easily solve and you are preparing for your GENCO examination. But suppose you are preparing for GATE examination, then preparation will be different. Then you can't prepare like this. You need to go much detail of that. So that discussion is not useful. So what I am trying to say, select particular topics, right, and read normally. Don't go in depth and go to the exam. Whatever I discuss with you, from this discussion, just I want to make you clear. You should not think like a GATE or any other exam. For GENCO exam, you need to think like a GENCO exam. You need a speed because many questions are there. You need a speed, you need accuracy. So what I'm trying to say, coverage is more. In GENCO exam, coverage is more, but depth, you don't require much depth. You don't require much depth. If you go with the ACE material, what is provided, where already ACE material is provided, go to that. You will get the very basic fair idea. If go to the previous year papers, whatever the available, not only Telangana state, you can take any state. Most of the all states having the almost same paper. So you will get the basic fair idea. So there is a huge difference in different examination and GENCO examination. So in GENCO examination, there are some few handy equations are there. Stephen-Boltzmann law, Fourier law, Newton's law of cooling, units, thermal conductivity, dimensionless number, critical thickness, fins, and all that. This, if you cover this, that is more than enough. That is a more than enough. So this is the effort from my side. This is the effort from my side to give you the awareness about this examination. Hope this session is useful for you. Hope this session something like you understand, oh, this is the way to prepare. So this is my small effort from my side and my academy, ACE Engineering Academy. We try to provide the best and best possible like solutions, best and best guidance for the students. So this is my effort from my side. So thank you all for attending this session. So in case in future if you need any kind of assistance, you can write in the comment box. Definitely we will respond to that, and we will try to upload as many as videos are possible so that the student community getting benefited. So thank you all and take care.